All right, let's actually get to some properties of logarithms. So here we go. Whoops, wrong way. Oh, wait a minute. How'd that get in there? Oh, Coach Stoney, we're not talking about those kind of logs. We're talking about logarithms. Ah, sorry about that. All right, here we go. Properties of logarithms. Let a be a positive number such that a does not equal 1, and let n be a real number. And if u and v are positive real numbers, then these following properties will be true. First off, let's talk about just base a. Basically, we're going to be talking about logs, not natural logs for a second. And what we know is this. If we have something of u times v, it's the same thing as having it of log u plus log v. It's kind of neat. So I think we'll show you an example of that here in a second. And guess what would be true about a division one? Instead of adding them, like you did up here for the multiply, on a division one you're going to subtract them. And the other one is this. If you have an exponent on a log, you can move the exponent from there just to in front of it. That might make some of the work a little easier sometimes for some of us. And the same thing's true for natural logs. The natural logs exactly like the ones on the left, except their base is e instead of any base. Because if this is true here for any base, it would also be true for any base right there, base e. So, how do we actually use this, Coach Stoney? Glad you asked. We're going to rewrite each of these in terms of 2 and 3. And so when you look at 6, if I have to use a 2 and a 3, how could I rewrite 6? It would be the same as 2 times 3. And that means that the natural log of 2 plus natural log of 3. And if you want to go to your calculators and check that out, you can. If you put the natural log of 6, enter, and then do natural log of 2 plus natural log of 3, enter, you're going to get the same answer. So how would I do this one? I want to use only 2 or 3. Well, first off, it's a divide, so I know that 2 natural log of 2 minus natural log of 27. I'll get rid of the division part. But how can I rewrite 27? Wasn't 27 the same as 3 times 3 times 3? Or 3 to the third power? And if I look at law 3, what can I do with that little exponent right there? I can move it actually out in front. Okay? So that would be the way to do that. That's how you could actually use the little logarithm to move some things around. And let's look at one more of these. Use the properties of logarithms to verify that the negative log of 10 to the 1 over 100 is equal to log 10 of 100. Well, first off, let's start with our first one. What can we do with that particular right there? Well, notice 1 over 100 is the same as the negative 1 power, isn't it? Remember, the negative exponent just moves things from the numerator to the denominator, denominator to the numerator. Now we can also move that negative 1 now there out in front, which means I have a negative times a negative 1. So what's going to happen to it? It's going to cancel and go away and just give me that. I could also do this. Now I think that's the answer to this particular problem right here. And you'd be done because we got it to look exactly like that one. But just for kicks, I just want to show you something. I could rewrite 100 as 10 squared. And what could I do with that 2? Move it out where? In front. Hey, wait a minute. And log of 10, 10 to the what power equals 10? Well, that would be 1. And 2 times 1 is 2. So that's a way we can use properties to help simplify things. Back in my day, without the calculators, we had to do a lot of things that way. So you should feel blessed because nowadays, you can just use that alpha window option 5 to solve a lot of your particular problems. Alpha window option 5. Sounds like I'm on Deep Space Nine or Star Trek or something. But anyway, there's our properties. But in this particular problem, we would have been done right there. I just wanted to show you that extra little side benefit.